We're going to continue on our factoring adventure here on target 7. So taking a look at these notes. So this is actually a special case of factoring. It's called the difference of squares. You can definitely factor these the same way that we did on target 6 if you'd like to, but it's actually, if you can remember this, it's so much easier to remember the shortcut that we're going to show you on the difference of squares. So we're going to start off factoring the same way we did on target 6, identifying A, B, and C. So A is 1, and if you notice, B isn't here, so it's 0, and C is negative 25. So are A, B, and C all divisible by a number other than 1? So again, looking for that GCF to start off with, and they are not. You can only divide them all by 1. So then we're going to look for this difference of squares situation with 3 questions. Is the B value 0? Yes, we already decided that. Are the 2 remaining terms both perfect squares? So is 1 a perfect square? Yeah. Is 25 a perfect square? Yes. Are they being subtracted? Yes, there is subtraction between the 2 of them. All responses must be yes before continuing. So if any of these are no, this is not the difference of squares. So since it is the difference of squares, we're going to take the square root of each term. So remember we had an x squared and we had a 25. So the square root of x squared is x and the square root of 25 is 5. So then step 4 says use your answers from above to write your 2 factors. Add the terms in one factor and subtract them in the other. So we had x and 5. So we're going to do x plus 5 and x minus 5. And then, just like we did on target 6, we're going to set each factor equal to 0 and solve. So if I subtract 5, I get x equals negative 5. And if I add 5, I get positive 5. Okay, so we're going to look at 3 different situations. So we're going to go vertical on this one. First step, so I'm looking at this first column, 9x squared minus 1. GCF, there is none. I can't divide 9 and 1 by the same number other than 1. Yes, yes, yes. So is the b value 0? Yes, there is no b value. 1 check. Is the 2 remaining terms, are they both perfect squares? 9x squared is a perfect square, 1 is a perfect square. And then are they being subtracted? Yes. So all 3 yeses, so we can continue on to the next step. Now we're going to take the square root of both the terms. So we're going to take the square root of 9x squared and the square root of 1. The square root of 9x squared is 3x. Square root of 1 is 1. And now we can write the factored form. We take those 2 numbers, we add them, we subtract them. And now we solve. So we set each of the factors equal to 0. And then we're going to solve. So this would be 3x equals negative 1. Divide by 3. I add 1. Divide by 3. All right. So it is much easier than the other factoring. You just have to remember that you can do it. All right, on step 1. Look for a greatest common factor. Both of those are divisible by 2, which would leave me with 4x squared minus 25. Okay, so now we're going to check our 3 things. So first of all, is there a b value? Nope, b is 0. Are the 2 remaining terms perfect squares? So look inside the parentheses. We have 4x squared and 25, both perfect squares. Are they being subtracted? They sure are. So now we're going to take the square root. So I'm going to ignore the 2 for a moment, but I'm not going to lose it. Or at least I'm going to try not to lose it. So I'm going to take the square root of 4x squared and the square root of 25. So this would give me 2x. This would give me 5. That sends us right into our factored form because we're going to take those 2 numbers, add them, and then subtract them. Oh, see, I forgot that common factor. So that common factor, what was it, a 2? That goes out in front. And then we set both of our factors equal to 0 and solve in both cases. So I'm going to subtract the 5 and divide by 2. And here I'm going to add the 5 and divide by 2. Okay, and then the last one we're going to do with the steps there. So starting off with a common factor, both of those are divisible by 4. So this is actually, if you look inside the parentheses, it's the same as the last one, they just look different. So yeah, we know it's going to meet all this criteria. We already know that the square root of 4x squared is 2x. We already know that the square root of 25 is 5. And so the factored form is just going to look different in the fact that we have a 4 out in front this time. But because the factors are the same as the last problem, these answers will also be the same as the last problem. Okay, so let's see what this will actually look like when we get to like a quiz test or target check. First thing that we're always going to have to do is factor out the common factor. So I'm going to factor out a 4 here. And then we're going to make sure that this is actually the difference of squares. So first of all, no b value, b is 0. They're both perfect squares, and they are subtracting. So then we take the square root of each of these. So that would be 5x, and then the square root of 1 would be 1. For your factored form, don't forget to put your common factor out in front. You're going to add your two numbers and subtract them. And then for your zeros, you're going to set each of these equal to 0, each of the factors equal to 0, and solve. So this would be x equals negative 1/5, and this would be x equals positive 1/5. So you're always getting a positive and a negative answer here of the same value. All right, I feel like we might have a GCF here. I'm not sure what it is off the top of my head. Let's check it out. Maybe we don't. I don't know. Maybe we don't. Can't figure out one. So let's go ahead and go straight into it. So if this is a none, so then we're going to take the square root of 625x squared. The square root of that is 25x. And then the square root of 81. So first of all, what I didn't check is are 3 things. So b is 0. They are both perfect squares. I checked that 625 was a perfect square, and they're being subtracted. So that's why I went straight into that factoring process. So then our factored form would be 25x plus 9 and 25x minus 9. For the zeros, you're going to set each of those equal to 0 and solve. So this would be x equals negative 9/25. And just like I said on the last one, it's just going to be the positive over here. X equals positive 9/25. All right, and that is the difference of squares.